With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem simply said a semiconductor X. So we can see here a semiconductor X is made by doping germanium crystals with arsenic. Now we know that arsenic is a pentavalent impurity, that is it has 5 valence electrons. A second semiconductor Y, so we can see a second semiconductor Y here is made by doping germanium with indium. Now, indium is simply a trivalent impurity or dopant, so it has 3 valence electrons. X and Y are used to form a junction as shown in the figure. So you can see that X is connected with the positive terminal and Y is connected to the negative terminal of the battery as shown in the figure. Now, we have to choose that which of the following option is correct. So how do you solve this type of concept? First, we need to determine that whether the X is simply a p-type or an n-type semiconductor and Y is a p or n-type semiconductor. Once we know that X and Y are which type of semiconductors, then we will see that if p-type, we know that a p-n junction diode is forward biased when p-type is connected to the higher potential and n-type is connected to the lower potential. Also, we know that a p-n junction diode is reverse bias. If the reverse happens, that is the p-type is connected to the lower potential and the n-type is connected to the higher potential. So this is the main concepts. Now, let us first try to check X types extrinsic semiconductor, that whether they are p-type or now X. You can see that X has been doped with arsenic. Now, arsenic is a pentavalent impurity. Now, what happens when you dope a semiconductor with a pentavalent impurity? Let us say arsenic. So, this is arsenic. It has 5 valence electrons. So, what it does is that it forms 4 covalent bonds with the neighboring germanium atom. 4 neighboring germanium atoms. So, you can see here it will form bonds with these 4. Its 4 valence electron will simply form bonds like this with these germanium atoms. Now, since this is a pentavalent impurity, then what will happen? It will have 1 electron, right? So this electron will be simply free to move in the crystal. This electron will be free. This will move in the conductor. So what will happen for every atom of the arsenic that you add into the germanium substance? There will be 1 increase in electron. So this will be simply, this will have majority carrier as negative type of charge carrier or electron. So this will be a n type. So X is simply an n-type extrinsic semiconductor. Let's better write here. So X is n-type. Now, if X is n-type, very easily we can understand that germanium, if it is doped with, now, if it is doped with indium, so what will happen? Indium has 3 valence electron. So it forms 3 bonds with the neighboring germanium atom, right? Like this. So indium has 3 valence electron and it forms bond with neighboring germanium atom. Now what happens is that there is a hole at this plate. So this is a hole and we treat a hole as positive charge carrier. So you can see here this indium will form bond with this germanium atoms like this. And there will be a vacancy in the crystal where the electron can jump. Now we treat the vacancy as hole or positive charge carrier. So this simply means that Y is simply a p-type semiconductor. So now we know that Y is simply a p-type semiconductor. Now we know that X is n-type and Y is simply p-type semiconductor. So you can see that if p-type is connected with the lower potential, this is lower potential and this is higher potential, and n-type is connected to the higher potential, then this p-n junction diode is reversed bias. So this is reversed bias. I hope this clear your doubt. So let us now try to check the options. So let's see, X is a n-type and Y is a p-type. So this is X is a n-type, Y is a p-type and the junction is reverse bias. I hope I have answered your question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.